for extraterrestrial intelligence, what do you imagine is on this next slide? Like, what comes to mind when I think of, what was it? Radio telescopes and Jodie Foster, I heard. Okay, so, here we have Jodie Foster in the classic film Contact, based on the novel by Carl Sagan, sitting in front of the very large array of radio telescopes and inexplicably wearing headphones, which has nothing to do with radio astronomy or SETI, but it made for a good movie so she could hear the alien signals. This is what most people think of when it comes to SETI, and this is how most SETI is done. The idea is that if there are alien civilizations out there, maybe, just maybe, they're broadcasting radio waves because there aren't that many ways to communicate across the stars. And either because they're trying to get our attention, or because we just happen to be in the way of some sort of interstellar broadcast, we might be able to eavesdrop, perhaps, and notice that there are other civilizations out there broadcasting radio waves into space just like we are every day. So aliens might notice us from our radio waves, we might notice them for their radio waves. This character, Ellie Arroway, by the way, is based on a real person named Jill Tarter, who was for a long time the head of the SETI Institute in California. So, except for the part where she finds aliens, this is a true story. And the whole Matthew McConaughey love story, that was made up. But other than that. But there's another kind of SETI too, because we can imagine if you have alien civilizations that are really ancient, like billions of years old, they might do amazing things over billions of years. They might build gigantic structures in space. They might do other things that we would notice, other than use, kind of 20th century radio technology to get our attention. And one of those things is called the Dyson sphere. But rather than me explain Dyson spheres to you, I figured I'd get an expert on alien technologies to do it for me, Dr. Captain John Picard. So here's Dr. Picard explaining Dyson spheres.
We have entered a massive gravitational field, Captain.
There are no stars or other stellar bodies listed on our navigational charts. However, sensors indicate the presence of an extremely strong gravitational source in this vicinity.
Can you localize the source of the gravitational field?
Sensors? I'm having difficulty scanning the object. It appears to be approximately 200 million kilometers in diameter.
That's nearly as large as the Earth's orbit around the Sun. How didn't we detect this before now?
The object's enormous mass is causing a great deal of gravimetric interference. That might have prevented our sensors from detecting it before we dropped out of warp.
Mr. Daly, could this be a Dyson sphere?
The object does fit the general parameters of Dyson's theory.
A Dyson sphere? It's a very old theory, number one. I'm not surprised that you haven't heard of it. In the 20th century, a physicist called Freeman Dyson postulated the theory that an enormous hollow sphere could be constructed around a star. This would have the advantage of harnessing all the radiant energy of that star. Any population living on the interior surface would have virtually inexhaustible sources of power.
Are you saying you think that people living there? Possibly a great number of people, Commander. The interior surface area of a sphere this size is the equivalent of more than 250 million Class M planets.
Dun 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 dun.
So everything about this is totally wrong. A big sphere like that isn't stable, it's not gravitationally stable, it would fall in the star, it's not mechanically stable, it would crumple under its own gravity. There's a lot of things, and there's no reason that the Enterprise, with like these amazing sensors that can detect a Class M planet light years away, would fail to notice such a huge object. Anyway, doesn't make sense, but it's a neat, cute little introduction. The real idea that Freeman Dyson had, and Freeman Dyson, by the way, is totally tickled by this whole thing. He loves that he got his name on Star Trek. Was just that if there are alien civilizations, they might need a lot of energy. And where is most of the energy in the solar system? It's not in oil under the Earth's surface. It's not even in uranium in the Earth's crust or anything like that. Most of the energy in the solar system is in the sun, and it's coming out for free like starlight. So the cheapest and most efficient way to get huge amounts of energy is just to build a lot of solar panels. So if you just put lots of solar panels all throughout the solar system, you could collect all that energy, and that would be a giant swarm of solar panels, and that's a Dyson sphere. It doesn't have to be this solid object. But what's great is if you type Dyson sphere into Google, you get all sorts of wonderful, fanciful pictures of things that, like this one's under construction, and I don't know what that one's supposed to be, and that one's made of hexagons or something. Anyway, it's a lot of fun to imagine how you might build something like that. Anyway, this is all completely, made up. But the basic physics of I need energy, I'll get it from the sun. If I get enough of it from the sun, then maybe that would be detectable, even without the Starship Enterprise to go and look for it, is sound. So that's another way that we sometimes do SETI. So what we would need to do to find something like that would be to see if maybe those solar panels pass in front of the star. So what you have to do is stare at lots and lots of stars for a long time and see if anything big passes in front of them. And amazingly, astronomers love to do that. And the reason is we like to find planets. So this is where I come in. So if a planet goes around the star, and if its orbit just happens to line up, and usually most stars that won't be the case, but some stars, their planets will happen to pass between us and the star every time they go around. And when that happens, the brightness of the star will drop every time it goes around. It'll get like 1% dimmer or something like that for a planet the size of Jupiter, and it'll happen very regularly. It'll happen every single time the planet goes around. And so NASA launched the Kepler Space Telescope, and Kepler just stared at 100,000 stars and for 4 years, and just waited to see if any of them got 1% dimmer. And it looked for this characteristic shape. It was looking to see the star just stay normal brightness, because that's what stars do, and then get 1% brighter for a few hours, because that's how long it takes a planet to go past, and then go back up. And if it sees that, then it found a planet like Jupiter. And if it sees something only get 1% of that dimmer, then that might be a planet like the Earth. And that was one of the things they really wanted to find, was a planet like the Earth going around another star. So before it launched, an astronomer named Luke Arnold had a great idea. And he said, you know that old theory, the Freeman-Dyson thing with the megastructures collecting starlight? Yeah. They probably wouldn't be circles. And, I don't know what shape you would make a planet-sized solar panel, but it probably wouldn't be a circle. And so just because it's not a circle, not because they would build triangles, he said, well, what if it was a triangle? Could Kepler tell the difference between a Jupiter-sized triangle and a Jupiter-sized circle passing in front of the star? And he found that it could. It was so sensitive it could tell the difference. So NASA had inadvertently, and against its better judgment, launched a SETI experiment to go see if there were giant solar panels around other stars when it was looking for planets, which is pretty cool. And he didn't restrict himself to triangles. He said they could do all kinds of stuff. Maybe you build something like this with louvers and flash Morse code at Earth and it goes by. I mean, there's anything it could do. But the point is, anything other than a circle would be really obviously not a circle. So you stare at 100,000 stars for 4 years, and if any of them happen to have things like Dyson spheres around them, you'll find them. And if you don't find them, then they're not there. And that's an interesting SETI experiment. So I thought that was a cool idea. So obviously Kepler didn't see any of those, because if it had found those, then I wouldn't have had to show you, Jean-Luc Picard explaining Dyson spheres. I could show you the above the full New York Times that we found Dyson spheres, right? Right? Well, that's what I thought. And then an astronomer named Tabby came to Penn State and showed me this star that she was studying and she couldn't really figure out. And she showed me how it was getting dimmer, and it was not getting dimmer like you would expect if planets were going in front of it. She showed me this. She said, look, here's the brightness of the star, and here it is getting 0.5% dimmer like you might expect for a planet. But it's not doing it in anything like that shape. Now, this up and down, you see this back and forth, that's actually a star spot. That's not the important thing. The important thing is it goes more or less flat, drops, more or less flat, drops and goes up, and then repeats it on the other way out. That doesn't really make any sense. That's not something a circle would do. And then it did this. Over the span of about a week, it got slowly dimmer, so nothing like for a few hours that a planet does. And then it plummeted and got about 22% dimmer than it had been. And then it went back up to normal over the course of another week. And planets don't make stars 22% dimmer. The only thing that can make a star 22% dimmer is something about the size of the star. So this is something much bigger than a planet, definitely not a circle, and we don't know what it is. And so she got really interested in it. This happened, by the way, to be discovered by citizen scientists. The astronomers had missed this. But there are citizen scientists, and you too can be one if you go to planethunters.org, who noticed this sort of stuff happening and brought it to her attention because she was the astronomer on duty when they did it. So she's studying this, trying to figure out what it is that they found. So this is one of Kepler's stars. And then in the final quarter, they didn't know it was the final quarter, but right before Kepler finally bit the dust and couldn't look in this particular direction anymore, it just went nuts. So there's at least 12 different things passing in front of the star here, and all sorts of different depths. None of these are circles. So all sorts of things went in front of the star. And so she was baffled. She was trying to figure out what's going on. She came to my office because she happened to be here, because she was asking everyone, do you have any idea what this could be? And I said, well, I don't know what it is, but you said any idea. So have you read this paper by Luke Arnold about alien megastructures? So she wasn't entirely amused by the alien megastructure. And so she decided that it was a giant swarm of giant planets. Here's Tabby. She was a postdoc at Yale at the time. Now she's an assistant professor at Louisiana State University. And they got a little bit of press. Citizen scientists catch a cloud of comets orbiting a distant star. The argument they made is that maybe there are gigantic comets, like enormously bigger than any comet in our solar system. And when they go in front of the star, they get these gigantic comae that are like bigger than the star, and they block all the starlight. It's pretty far-fetched, but I'm one to talk because I'm the one that said aliens. So anyway, she wins. So that could be what it is, and she started this big campaign to try and figure it out. In the meantime, I'm like, well, look, those people with radio telescopes, the Jodie Fosters, they're just shooting blind, right? They're just looking wherever, at any old star. If you're going to look anywhere, you might as well add this to the target list, because it's the best shot you've got. Because, you know, maybe. So I contacted Andrew Simeon at the Berkeley SETI Research Center, who uses the Green Bank 100-meter radio telescope in Green Bank, West Virginia. It's the largest moving object on land, apparently. You can point it wherever you want. And I said, why not, if you're using it anyway to look at stars, why don't you look at this one? He thought that was a good idea. He, Tabby, and I put in a proposal to use this telescope and just check, just make sure there's no radio waves coming from it. So we didn't do a press release or anything, right? I don't stand up and jump, look, we might have found aliens. This was just, can we please use the telescope? And I knew something was up when Andrew was in Washington, and he was giving congressional testimony about how NASA should fund SETI, because it doesn't. And I saw this tweet by a reporter I know at the Atlantic. Last night I had dinner with the director of the Berkeley SETI Research Center. We had a fun talk. And he wrote an article about SETI and the return of SETI. And I was starting to get worried, because he did ask the question I was worried he'd ask was, so do you have any interesting targets? And it turns out Andrew told him, well, you know, there's this star. And Ross is a really good writer, and he wrote a really cool article. And I love this article, but I hate what it did. It's called The Most Mysterious Star in the Galaxy. And it's about this star, which is, frankly, the most mysterious star in the galaxy. And he interviewed me right before it went to press, like right at the end, after he was like, it's gonna go, what do you want to say? And so I blurted out, it looked like the kind of thing you might expect an alien civilization to build, and they made it the pull quote. And the media loved it, oh my goodness. BuzzFeed was one of the more responsible headlines that we had. A scientist really found an alien megastructure around a distant star. The leading theory is that the light patterns can only be explained by, by phantom comets, but extraterrestrial activity still hasn't been ruled out, which you can say about anything. Anything. This talk could be the result of alien activity. I haven't ruled it out. And so this just got completely out of control. It was just amazing to watch this whole thing happen. So here is a famous astronomer weighing in on his opinion.
Excited right now. There is a star out there, KIC 8462852. A lot of 852 fans out there tonight. Explain to people what the Kepler telescope is.
It's a telescope conceived and designed and launched with one purpose in mind: to find Earth-like planets orbiting sun-like stars.
Okay, and they do it.
And they found there's a catalog of nearly 2,000 of them now.
And they do it because they're looking for a transit, a planet going between us and the star that dims the
stars are so bright you're not going to be able to see a planet reflecting its light next to it. It's like looking at a firefly next to a Hollywood, what do you call it?
Next to Seth MacFarlane.
So you view it indirectly. So you watch the planet move in front of the star and watch the light of the star dip in its intensity.
But this magic jam is different.
It's got stuff we don't know what it is.
It's dimming by 22%, not like 1%. It's a big dip, and it happens frequently.
We don't know what it is.
Right. And one thing that's been thrown out there, have you heard about this, Seth?
Yeah.
Tell the people what they think
it's the Borg.
They think it might be an alien. They're saying alien megastructure is one unlikely but possible answer.
Excuse me?
Yeah? Yes, the promising young man in the front row.
Just because you don't understand what you're looking at, does not mean it's aliens.
Right, it could be God. It could be God.
I read this on BuzzFeed.
I'll tell you what it is, my friend. This is what it is, okay? It's the Ring World, okay? That is from the classic 1970 Larry Niven novel. It's a ring world. It's a ring of material, 93 million miles in its radius, with shadow squares to create day and night checks on the outside. If you live on the inside, it spins at 770 miles per second. It gives one gravity outward. The atmosphere is on the inside. We found the Ring World.
Well, we just don't know what it is.
It's the Ring World. I have a picture.
Actually, there was some really terrible media coverage. I don't have enough time to make fun of like Michio Kaku and people who just did an awful job. One of the better, well, that was one of the best jobs I saw. This one was kind of surreal though.
Astronomers have discovered a mysterious object orbiting a distant star and speculate that it may be a massive alien superstructure. So that's it, folks. We're all dead. We had a good run, didn't we, Jones?
I'm sorry, you're not even going to tell a joke?
Ain't no joke, man. The aliens are coming. And when they do, one of two things is going to happen. They're either going to eat us or they're going to have sex with us. That's the only reason people travel. It's just true. Anytime my friends come back from vacation, they tell me two things. What they ate and who they had sex with. And I'm scared. I'm scared that soon Earth is going to be alien Thailand. Where strange alien businessmen make us do weird tricks with ping pong balls. I don't got the hips for that, Colin.
I'm sorry, alien businessmen, what are you talking about?
Oh, don't act like you don't know what I'm talking. Listen, I live in an all-white neighborhood, okay? I do. And every time I look out my window, I see white people jogging. All of them. And I'm like, what are these white people training for? Now I know. Y'all trying to leave us.
I mean, yeah, but...
So it was kind of a surreal couple of weeks. The worst part was that we hadn't put out a paper. Normally, when you make an outrageous claim, it's because you did a press release or a paper, and you have something. And when a story like this happens, what reporters do is they call their favorite astronomers that they trust to give good advice, and they're like, so what's up with this claim? Should I publish it? And they send the paper and say, read it and tell me if you think this is right. We hadn't done anything. We hadn't published a paper. We just asked to use a telescope, so there was nothing. So I'm getting these famous astronomers getting calls from reporters saying, Jason Wright says he found aliens. What do you think of that? Which was not, I think, great for my career. So the thing we have to do is figure out what it is. And the only way to figure out what it is to catch this thing doing it again. And the problem is, if you want to get time on telescopes, it's really hard. And if you go, we want to go look at this star because it's weird, they're like, yeah, there's a lot of weird stars. So if you say, we want to look at this star because aliens, they don't even read your proposal. So it's actually really hard for us to get time to study this thing, even though it's a really cool mystery. So there's so much popular attention. Someone told Tabby, people would fund this. Citizen scientists found it. Why not get citizen scientists to fund it? And so she went to Kickstarter, and she said, I need $100,000 for a year's worth of telescope time on a private telescope network. And people were like, yeah, cool, $100,000, go. Anyway, so did anyone contribute? Is anyone here a Kickstarter backer? No? Okay, so no one got the t-shirt. You can still go, we need year 2, please contribute. Okay. So we got the money, we got the time, and we've been monitoring the star for half a year now, waiting for it to get dimmer. And the reason is, if it gets dimmer again, and we know it's happening in real time, then we can ask whoever's on the telescope that night to please take a spectrum. A spectrum is how astronomers figure out what something is made of. When the star gets dimmer, something is blocking the light. And whatever's blocking the light has a characteristic pattern of light that it absorbs. And by checking out that pattern, we can determine what it's made of. We can see if it's made of normal astrophysical dust, if it's some kind of ice from a cometary tail, or if it's something we've never seen before, in which case we get to keep playing this alien game for a while. So I got a hint when I was in Berkeley from Tabby. She texted me, and she said, I think it might be getting dim. And so we kept waiting for the next measurement to come in, because if it got dim enough, then we could tell everyone we knew, quick, take a spectrum, and we can finally solve this mystery. So this was me all day, as I waited for the measurement to come in from the Canary Islands, telling us that, in fact, it was dimmer, and we could, push the big candy red button and tell everyone to take a spectrum, and it was cloudy in the Canary. No, the telescope broke in the Canaries, so we had to wait until the El Paso telescopes came up, and we could finally get a measurement. And sure enough, it was dimmer. And so I tweeted this out, alert, Tabby star is dimming, we call it Tabby star. This is not a drill, astrotweeps on telescopes in the next 48 hours, spectra please. 735 retweets, 1,000 likes, that's a lot, for my account anyway. And the Atlantic really loved it, the alien megastructure star is dimming again, and we got lots and lots and lots and lots of data, and we're working on it. And we will definitely let you know as soon as we have a good answer for you. But people really came through. I mean, astronomers we've never heard of all over the world were emailing us saying, what can I do? And I'm like, take a spectrum. I'm like, okay, and they gave us spectrum. So we actually have so much spectra and data that we're swimming in it, and it's taking us forever to sift through it, which is why it's taking us so long to give an answer. Anyway, you want to see the light curve, because it's getting dimmer. Here's what it's been doing. This is hot off the press. One of the rewards for the Kickstarter backers was that you got to name the dips. And so the people who donated, I don't know, $1,000 or something, got to name them. So the first one is named Elsie, and the next one was named Celeste, which I think is cool. And so these are two different telescopes in Maui and the Canary Islands. And you saw it got almost 2% dimmer, and then it stopped, and then it did it again, and then it stopped. And since then, actually, for the last 2 weeks, it's been 0.5% dimmer, and it's not going back to normal. And that doesn't make any sense. And I really don't know what that means, actually. Which is one reason we haven't written the paper, because the dip hasn't stopped yet. And we want to show the shape, and it's still going. This could go forever. I don't know what's really going on. But I have to finish the story. We got the telescope time, not the first time. They told us they weren't interested in looking for aliens around it, but after it was on Saturday Night Live or everything, we resubmitted the proposal. They're like, yeah, okay, you can have the telescope. Same proposal. So we went to the telescope, and we used the gigantic supercomputer they have, and we can search a billion channels at once. It's ridiculous, this back end that they've built. There's a billionaire in Silicon Valley named Yuri Milner who's put $100 million into this effort. So they've got this crazy supercomputer. Here's Tabby. In front of the supercomputer is data from her star comes pouring in. This is on loop. She's not really sitting there that long. But we went and we collected a lot of data. And if this dip weren't happening, that's what we'd be analyzing. But we're too busy with the photometry. Anyway, I wish I had a better conclusion to this story. But once we produce all the data, I promise I'll tell you what we've learned. Anyway, the long and the short of it is you can do SETI this way. That's great. And in fact, the only way to know for sure that you found aliens is to find some kind of distinct marker of technology. A star getting dimmer could be a lot of things. I Love Lucy can only be alien television, right? So the people that have done this have worked for decades on this kind of thing. And I feel kind of bad about the crazy media hype that happened when I haven't put my neck out as a professional for decades, dedicating my life to this kind of thing. These people have. Jill Tarter, who was the inspiration for Elliot Arroway, Dan Wertheimer at Berkeley, Frank Drake, who's been doing this longer than anyone, who did the very first SETI survey back in 1959. And they've spent their whole lives doing this. And they're the ones that I think should be getting the attention on all of this. So I like to put them up just to say that. Anyway, I will let you know, I promise, let the whole world know once we know what's going on with Tabby Star. So that's the story of how the media told everyone I found out these things.
So I have two questions. I don't know if we have time for that.
Question and a comment? Which question?
So my first question is, you said that the solar panel megastructure probably won't be like a circle or spherical shape.
Yeah, a solid sphere doesn't make a lot of sense mechanically.
Okay, but to me, it seems like a circular, maybe parabola shaped, which for two-dimensional cross section would be a circle. Seems to make a lot of sense to me. Is there any particular reason why you said?
The question is that maybe a circular aspect to a solar panel might make a lot of sense. So maybe they would look like circles. I don't know what shape. I don't know what shape alien planet-sized solar panels would be. If they're circles, we'll think they're planets and we'll miss them. But if they're not, we would have seen them.
Okay.
And so there's not a lot of them.
And my second question, just because I don't know that much about solar science, astronomy, is how rare is it to see stars make like very rapid decreases in their intensity to the like 1 to 10%?
So how much do stars naturally vary in brightness?
Right, because they do.
Yeah, it depends on the star. Giant stars tend to flutter around at a couple percent. Star spots, if they're really big, can make things vary by kind of 1% or something like that. But normally it happens every time the star goes around, so you see a rotation period. Well, we see that with Tabby's star at the 0.88 day level. But these big things that we see, this is the only star that does that. In fact, there's a citizen scientist, one of the first ones who noticed this. He has looked at every single star that Kepler has looked at himself by eye to try and find another one of these. That's over 250,000 stars. He's looked at all of them. He's amazing. And it's still the only one.
Is there any other like countries that are using their telescopes to try to look at the star?
Are there-
It's sort of like beat us to the chase.
Are there other countries looking at it? Yeah, I mean, some of the data I showed you were from the Canary Islands. Yeah, telescopes all over the world. When I hit the big red button, so to speak, we got data from around the world.
And I also had a second question. The James Webb Telescope,
James Webb. Yeah.
could that possibly be used on this, or is that for the cosmic background?
Yeah, no, we could point the James Webb Space Telescope at this, but its particular suite of instruments, that would be very useful. And I would love to point the James Webb Space Telescope at this star, because if whatever's blocking the light, whatever it is, if it's close to the star, it must be warm. If it's warm, it has to give off infrared radiation, and that's what the James Webb Space Telescope is designed to detect. We can't detect any abnormal levels of mid-infrared radiation coming off of this star, which is part of what makes it so weird. There are other stars that do something like this, but they all have mid-infrared radiation.
I've got one question.
One question.
So, how did Tabby know that the star was about to start dimming?
How did she know that the star was about to start dimming? Well, she didn't, in truth, but I think what you might be getting at is that she said in her paper that we might expect another dip in May of 2017, which she'll say was mostly a laugh. It was a wild ass guess. And when it happened, everyone was like, oh my God, you got it right. And she was like, no, that was a guess. The two very deepest dips occurred almost exactly 2 years apart. And then if you add another 2 years and another 2 years, that was earlier this year. But most people thought it was in March. She said maybe May. That gives you a sense of how fuzzy that prediction was. So I don't put much stock into it myself, but it happened. Oh, one more.
So the assumption is that only objects that are within the solar system radius of a star cause it to dim?
It is almost universally true that if a star gets dimmer, the question is only things within a solar system can make it dimmer. It's almost universally true that if we see a star get dimmer, it's either the star itself or it's something orbiting the star. I think what you might be getting at is, could it be something between us and the star or something in our solar system causing it to dim? And before this, I would have said that's so unlikely we would never see it, but this is such a weird system that we've been forced to resort to thinking it could be something in our solar system blocking the view, like a thumb on the camera, the outer solar system, Planet 9 maybe, or something in the interstellar medium between us. And in fact, I'm now favoring the idea that there's a cloud between us and Tabby's star that's causing it. Most people don't like that though, because it's really unlikely.
So you're saying you discovered Planet 9?
I discovered Planet 9.
All right. Thanks, Jason.